Hey everyone, I've got a real disjointed video as I seem to have every time. They are just difficult for me to film because I'm not always doing the work, so I'm trying to show you the whole job. And yeah, so here it is. Enjoy, I hope you learned something and leave a comment, all that jazz. Yeah, timber floor in here looks perfect. What else? So I've got in this video, there'll be some IR testing for the mechanical board which is out there. There's going to be some medical switch panel stuff, bit of the Dali control from the last video, so you can check that out, sort of just how it was wired up. What else? You'll just have to wait and see, I suppose. Enjoy. Alright, we all remember this board. The mechanical contractor needs this energized and he needs that energized, so that's going to be this little segment. I've got some clips of the testing that we did, testing that, the 180 set and the Radox, which is that supply there. It's a 16mm Radox. So yeah, that's going to be this little segment. Enjoy. I hope so. It's there, is it? Alright boys, home time, let's go! Go! Alright, I've got to get this this supply on, but that also means that I need to turn this on. So I've got to test that half of the board. I haven't really got to it yet, so let's get into it. We'll have a look at the guts of this this main switchboard. So I'll flop you around. Alright, so up in here we have the bus bar way for the safety services. Okay, so our incoming feed for this section is actually those cables here. They come off the bus bars in that section and it comes to the changeover switch here. Now again, this was going to be a whole separate video, but I'll just breeze over it at the moment. This switch here is the changeover for the mains. So the mains, so as you can see, it's off now. So it's live to the top of this switch, okay? And then that goes to the bus bars which feed, see there's two cables logged off there. One of those goes up to here, that feeds these bus bars, which feeds those safety services. And then the other set, it goes up here, and goes into here, into the safety services. Alright, so what this one does is if there is a blackout, the control here will detect and it will send a signal to the generator through one of the control cables that we've got. I haven't terminated yet, but that's it there. So it'll send a signal to the generator to start. When it gets that signal back saying that the generator is running, this switch will turn off and then this switch will turn on. So it's a break before make in this case, because you can't obviously have, you don't want to, it's not so critical when you're swapping to the generator because the power's off, but when you're swapping back, when the power does come back on, this needs to turn off completely before that one turns on. Otherwise you could potentially have like a phase-to-phase short and this entire switchboard would probably blow up. Okay, so in a nutshell, that's it. I'll do a more in-depth video on it down the track when I'm actually hooking some of this up and actually commissioning this. But in the meantime, I need to get this switch on to power up my safety side because there's some essential bits and pieces that the mechanical guys want to look at today. So that's fine. So basically what I've done, I've just done a mega test on the outgoing side of this. I've turned this switch on, which powers that, but because this is isolated here, I can safely test from the bottom here, through the bars, up through this switch and all the bus bars in that section. So I'm happy to turn this on now. I can turn that on as well because I've tested through, okay? But before I turn that on, I'll isolate this and just go through it step by step. So this has got some covers. I'll have to put these covers back on. I'll pop the fuses back in for CT metering in this panel, and yeah, we'll meet you now. Just for a video, but you can see how heavy duty these springs are. Right, so that's the guts of one of these isolating switches. Yeah, so that's not a breaker, it's just a switch. So I've just popped those fuses in, which has livened up the little circuit breakery boo panel. I'll just leave that off for the minute because it's not really necessary at the moment. And yeah, so I'll put this cover on, hop the batteries back in because obviously it needs batteries to run that while you know, the power's off. Just leave it at the control, so there's a little charger and shit. I'll put all this back together and then the front cover on, and then I'm happy to turn these on because, you know, at least I've got that in front of me if it explodes. So I mean, it shouldn't explode because I've tested it, but you know, you always hold on to your packer and fucking look away. That's the go. Alright, so I got the battery in. The battery provides this with 24 volts even when everything here is off, so that's fucking good. And we'll just move right along. That's powered up my controller here, I think. It's all the lights just doing that. So I think if we go to manual, I'll just put this cover on. Right, so that warning is to be taken exceptionally seriously. If you manually turn both of these on, it can create like a dead short between phases and you will probably die. So we'll I'm pretty sure I can do it manually, but since this is all working, we'll just do it on here. So if we hit manual, right, and I guess okay. Voltage mismatch. Well, yeah, of course there's a voltage mismatch here. I'll fuck around with this and work it out. Alright, so you gotta kick that little toggle there down to manual, and then this is already charged, see, so you pump it up. All it needs is an input to just yeah. Okay, so it's discharged. Now you can pump it back up again. Right, that turns it off. And it's charged, and so it's ready to fucking pop on. And that's ready to go. So that should now have energized my bus bars up to here, so I'll check it there. And then we'll, yeah, we'll just pause this and I'll just check it. And if you flick it off, auto here, it'll fucking auto charge it and then fucking change state. It's kind of scary the first time that sound happens, but it's alright. I did one of these last year, so I've just checked that with the meter. So we got power to the bottom of that main switch. Now I'm confident turning that on because we mega tested through and the whole chassis. So we'll just work out which circuit. I think it's this one here that needs to go out, so I'll get someone to go and bell it out, just make 100% sure that's the right cable, and then we'll mega it, and then we'll fucking flick it on for the mechanical sparky who's out there waiting for me. On all of them? Yep, so go to white now, and that's the result you want. Off scale high. Press and hold. Good. Now what happens if you go to neutral? Blows up. No, it's linked at the board, so you should get 0, right? So just for shits and gigs. Cool. Alright, so now transfer your earth plug to the red face. Oh, you're right, you could have done that too. Alright, so go between all the phases. That's a little wonk. Press and hold. That's suspiciously low, actually. Go again, just press and hold it. What the fuck? Go to neutral. Oh, that's alright. Alright. Do it again for the gram, mate. Go on.
Not doing it.
Thank you, Fluke. Right, so that unit there, we'll zoom in a little bit so that you can see, but if we're going to focus, It's called a power tag, so it's a Schneider, it's got a little tail that shoots off. Now, that gives you a bad reading on the insulation resistance. That gives you about 8 mega ohms, so it's not a problem because as soon as that turns on, it clears itself. It's not an issue. And just to prove it, I just disconnected all the tails and I had 500 mega ohms between. It's only to phases. If we do from earth to phase, it's completely clear, but phase to phase, you get this weird 8 mega ohm reading. So just a little tidbit for you guys. Just going to test it here, check the voltages are all right, and then this little job's done. So, yeah. So you get nothing there, right? Shouldn't get anything. Between there. And there we go, this one. 240. Lovely. So I'm down here in the basement. There's some plant down here for fucking different things. So a couple of air conditioning control boards and a control panel. So the AC fella just asked me to liven up these boards down here, and you know, due diligence. You need to go fucking check for yourself. The guy that did this was on site. Oh fuck! It must have been like a couple of months ago. Those cores are apart. I'm going to get a good insulation resistance reading. The board is an earth, good insulation resistance reading, and I could have just flicked the switch, turned it on. Because the fella said that, yeah, you know, the other AC guy, he didn't say anything about them not being terminated, but this one's not terminated either. You know, no earth on the panel. So it's just a little PSA, like, mate, you've got to go and check yourself. Make sure you see it with your own eyes, because you know this could have been fucking a seriously dangerous situation. You know, it's experience, though. You know, I always go and check. I double check that it's the right cable, we bell everything out. But you know, if you're unscrupulous when you're energizing stuff, it can be pretty sketchy. So you know, just keep an eye out for it. I've finally got the extension bits of cables for these VG block cables. So that one's obviously, where you can see, that one was short enough being on this side. So these ones I've just got some 10mm black flex, and I've got some barrel lugs here and some heat shrink and some 10mm barrels also. So that's just going to come, I've just got to gas that, torch that down, and then get it across to the bar. Got 2 of them to do. Alright, just a super short and sweet overview of this again. We've got the gas panels, this is the plates for the nurse call, the data, essential outlets, and then this is the backing plate. Cover plate, cover plate. I like your last one. Done and dusted. So the only problem I've got is my nurse call plate doesn't quite fit in this gap. There's a little lip on the bottom that I'll show you shortly. Maybe not in this video, maybe the next one, but it doesn't quite fit in there, so I'm not sure what. I'm going to have to talk to the nurse call people and ESCO and see what the fucking go is. So, yeah. fucking got those mains on there. I've got one of the boys to fucking terminate this this week. I've got all the breakers, so I can terminate that, make that look pretty. This is a little cafe section. It's not a huge room, but we've got a coffee machine, like a fridge, a couple of above bench points, toasters. Like a lot of them are on dedicated circuits, so I don't know what the fuck that is, but yeah, so nothing too crazy in here. Some data points for the FBOS machine, and yeah, just we'll have to cut a couple of lights out, but you know, just a little local subboard, so easy peasy. Nice. Too bad you can't see it. Pretty dusty here this morning, boys. I'm a bit crook when you're checking the chassis of a board like this. Got this guy on server. There he is. Check my cables coming in, my mains. But you also want to check the chassis as well, so the chassis doesn't blow up. But what you got to do before you measure between anything here, you want to pull these fuses for the CT measuring out, because they will give you some wonky readings on your mega test. So just keep that in mind. Had all the waterproofing done on the concrete roof. It's short and sweet here, but yeah, there's some trim to go on that there, but a couple of downlights in that little section there, but this is us otherwise. We've got our light fittings out here. It's just a few button lights, a little bit of conduit work up there, that button light and exit, that's about it. All this is all hooked up. These glands are all good. And these cable ties on us, that's the mechanical fellas, so those glands are a bit of a mess. I still need to I've got a box coming for this, so I have to get up here and put that up at some stage, but yeah, that's good. Get that upskirt shot. Oh yeah. It's there, is it? Alright boys, home time, let's go! Go, go, go! It's just a fucking endless comedy show with these two muffins. And scratch my pole. I'm waiting for them to do something stupid, but oi! Alright, so this is the arrangement for a cardiac protected room. So we've got two feeds from my equipotential bond. Okay, so one of them strictly does the earth on the outlet, and the other one does the back box and the frame. So that's, if you can see, so the back box is earth with that yellow tab log, and then the frame, it's a little tricky to get that on, but hopefully everything fits in the back box here. But just about to screw it on. That's my first one for the cardiac room. It's a 15 amp outlet for a laser. Alright, one down. I'm still having some fitment issues. I've got that outlet up as far as I can go, and that RCD is down as far as I can go, and there's still some clearance problems, but all in all it doesn't look too bad. So I've just labelled it on the top, and then we're going to get some traffic labels made for these ones. So that's the easiest one that I've got in this room. Just started with that one, and then we'll move on to this fella, which is over here. It's got some data, a central circuit and a UPS circuit. Right, so this is going to be a bit of a I'm a dumbass moment, but those screws are meant to be behind this plate. So this is the cover plate for, it's got the back box and then a separate back plate for the screws to fix into. So this is one of the line isolation overload monitors. Okay, so it just, all these do is they measure the milliamp current and the output current of the whatever's running on the circuit. Anyway, I just did that one and I struggled getting these screws in. I'm getting a call, I'll have to pause. Derailed. Okay, so those actual screws in there, they're like it's like a panhead style screw. And I thought, like, yeah, okay, I pulled them out and I screwed this plate back in. And the plate was sitting like too far in. Like these are obviously very small screws just to hold this on. But I'm an idiot. Like they're supposed to be there, and then this little clip will clip over behind. You loosen that screw, and then it will clip on behind and hold it onto it. So just a little dumb moment. I struggled getting that on. I went and got one of the other screws from one of the other cover plates to pull it forward, and then I screwed them one at a time. So it's on tight. It's all good, but if I have to take it off, I won't be able to get the screws on, so I'll have to swap this around. Not a big deal, but I'm just it's the first time I've done this thing, so I'm just learning. So you guys are learning too. Right, so this is quite confusing because of the earthing in this room. If you remember, I've got my earth bars up there. Right. So that's for the equipotential bond. So basically what's happening is I've got a feed from that bar for the earthing of the panel, and that goes into a 2-screw connector. It earths the panel, and then that cable comes down to here to earth this panel. Okay, so there's a panel earth, and then that's separate to the earth for this, which is different again. The earth for this is different again, so that's a separate feed up to the bond, right? And we actually just cap the feed earth from the switchboard, from the distribution board. We just cap that off, and that's maintained through the cables, okay? But then up to all the circuits, and anything that plugs in is earth to that bar, not to these earths. So these earths are capped throughout the system. They're continuous through the system, but they're capped and separate because we need a lower earth resistance to that point and to everything else in this room for safety on this thing. So it's a cardiac protected room. This is the only room, and like the little anesthetic bay there. They're the 2 cardiac sections in this job. So I just want to be doing this, like I'm running this job, but I want to do this myself because this is particularly tricky and I don't want an earth to be left out. Earths are obviously a protective cable. I don't want anyone else to get confused with this system because it's confusing me. So that's it. Just a little run through on it, and then obviously we've got our active neutral in, but because this is a line isolation transformer protected circuit, we actually don't have an earth connected to the rest of the circuit. Like there's a protective earth, but it actually won't trip. I'll do a video on this later. It's very confusing, but I'll touch an active cable off one of these transformers and you won't get a belt. So I'll do that on video at some stage, I think. It's hanging out a bit, but fucking can't get it in anymore. So the earths are separate because of this cardiac room. so that's all done. So this earth is from the equipotential bond bar, which is up there. And then there's another 6mm earth to the back box here, which I can't show you just at the moment. So the thing's in a pretty precarious position, and the earth in the circuit here, again, I'm probably repeating myself, but it actually doesn't get hooked up in the circuit. So we just cap it off, just put it in a connector. And it's all to do with like keeping the resistance low in this room. Like earth potential, like touch, it's for touch voltage really, because someone having a heart surgery can't handle even the tiniest little bit. I think human skin has somewhere between 100,000 and 200,000 ohms of resistance, so, but I mean if you've got your chest cavity open and your heart's right there and you cop a very tiny voltage, it could do a bit of damage. So, as far as I understand it, that's the reason that we're doing this equipotential bond system. Right. So this is one of the most basic medical services panels. It's just an RCD with a number of outlets on it. The outlets are red in this case because they're essential, which means that they're on a generator backup. Pretty well everything in this in the operating theatres here, this is one of the theatres. Everything in the operating theatres is an essential circuit. And then if you see any blue outlets, they are UPS backup circuits. So I just want to make sure that little LED cable is behind, so that when you tighten up the terminal, the 2.5mm cable in this case is getting squashed, not that little. You don't want that little even though it's ferruled in front, it's going to get damaged. Tightening up this terminal. If you put it in behind, the screw's not going to put any pressure on it, and it's going to get sandwiched in there pretty nicely. Just a bit fiddly getting it all in. So this is the problem with these freaking pre-built, pre-set up outlets. Look at, I've gotten like a full turn on these terminals. You know, it's got a quality control sticker on it, and it's like, mate, it's not tight enough. Alright, so that's it. That's the whole thing. That's a little power available light, and then on the RCD here, it's got a light to show that there's power to the RCD. So if this trips, that light will go out, but that light will stay on. If the circuit breaker back at the board trips, this light will go out, and obviously that one too. Right, so just need to make sure that the cables tuck in nicely. I might need to just trim that slightly, the vinyl. This knife is absolutely excellent. I've never been a breakaway blade knife kind of guy, but if Nipex makes it, I'll give it a go, and this has been really nice. Snap blade knives, what is it called? pull the cabling in, make sure that's not going to get squished against the box. That's a nice snug fit. Where are the screws? Here. Still playing with this thing, it's quite nice. It's good for doing these up. I found on C-clips though, it over tightens on C-clips unfortunately, but that's a metal back box, so it's nice and solid. That's still a little bit wiggly from when I had it undone. Just put that up. And then the cover plate here. The cover plate, I've had issues with these cover plates lining up exactly, but since this is a single plate, it's a stainless cover plate and these are stainless screws, so a little bit difficult to get going because of they're not magnetic. Just fall off your drill bit. Right, now we just need to check that everything is level. Look at that. Your error might be on, but that is actually off by a tiny bit. Let's see if we can fix it. Just got some of these window packers here. So what I was doing, where's mine? Just getting in there. So I'll just tap them in. Easy. Don't need the vinyl, dickhead. There we go. Look at that. It's been a long day, but I've got all these on, so it's just a little double banger. This is some Essential and UPS, some data points there. That's a gas one, so the only thing I have to do with the gas is just earth it with this this tail here. The little earth bolts there, so I've got to do an earth bolt and then a loop for the front panel. I've put my equipotential test point on, so that was hard as fuck because there's two 25mm tails coming off that with that are lugged. This one's going to be a bit of a problem. We should have two switches here, so I'm probably just going to put a double gang plate and two switches here and make that one redundant. I'm not sure about that yet. Maybe put a blank or something on it. It's just another little panel. So this one here is the line isolation monitors. There's two line isolation monitors here, and this is the pendant RCDs. Then we've got the alarms for the UPS system, and then there's some outlets in the ceiling here that are like individually switched. 7 off, yeah. And then this is the last, or second last panel, which is just some RCD protected data outlets there, some data points and two UPS outlets. And those outlets aren't RCD protected, they are protected by isolation transformer, those two. All right, these points I don't have yet, they're just single integrated RCD points and then two data points to go with them. The reason the data points aren't done is because I'm not sure about the size of the plate yet. I'm getting them all straight. It makes a difference because I think the size is a little different, and this is the first First one that I started on this morning, that's a 20 amp outlet for a laser, like an eye surgery laser, as far as I know. So yeah, that's this room, pretty well complete with the medical panel. So I wanted to do this one just to iron out any issues with the panels so the boys can do the other 3 rooms. And yeah, I've basically got it all worked out for them. So yeah, late in the day, I'm a bit dirty and stinky probably, so I'm gonna go home and probably have a brewski. Cheers. Oh! Handyman gets onto all the tight places. Right, so this is a look at the back of the UPS system. So there's a cover plate that comes, that cover plate there that comes out and down and sort of just clamps, well, it doesn't clamp, but it sort of touches this. I'm not happy about this, but I don't really have an option. So yeah, this fucking like skyhook loop here, I mean, I don't like it. The cables are technically unmechanically protected. I mean, this is a locked room. It's obviously a plant room. There's fucking equipment over there. You know, they're exposed here, but I just don't like the idea of skyhook there. So, but it is what it is. I asked this UPS manufacturer to supply some photos of what other people have done in the past, and they sent photos of this. It's basically the same shit. Right, so had to remove these to Megram. All this electronic nonsense in there. So in a nutshell, this is just the super quick version of how this works. Feed from the main switchboard, right, and then this set here goes to the bypass switch over there, right, and from the bypass switch it goes into the board on the left over there, the UPS power board. So this is the power UPS. The lighting UPS is tucked in there. It's a fucking tiny little thing. So yeah, I've just got some control to hook in, but they just go in those little terminals there. And yeah, I need to change the phase rotation. I'm gonna do it back in the main board because doing it here is a little bit difficult. And if I do it back there, all that like this here, that's fucking impossible to change. So I'm not touching that. I'm just gonna reverse the polarity. One of the phases back to the boards because this needs a clockwise. I don't know why it needs a clockwise, but it needs a clockwise. So I'm going to do that now, and then we'll do another test, and then we'll power it up. So the guys are coming to commission this tomorrow. See if they're just going to hook up the batteries as far as I know and just make sure everything works. But yeah, so I'll leave this here, and I'll see you shortly. And that one, and that one. Oh, this is a little interlude to check this awesome meter out. Weapon, side note, but we're commissioning this UPS system, so ignore the janky setup here, but we actually need to drop the size of the cables. We've got 50 mils running here, we only needed 35s. We need to link the main supply there with the auxiliary, so we've got this janky setup at the moment just for testing and commissioning, and then we'll correctly drop the size of the cables and terminate them properly. So anyway, having some trouble internally in the UPS system though, so I'm just giving the technician a hand. No rhyme or reason, but this fuse here and that fuse there and that fuse there are all blown. So this one up high is a DC fuse for something to do with the batteries. I'm not an expert at this, at anything, mind you. Just give me a hand. And that fuse there and that fuse there are blown. So obviously there's no black marks, no smoke, no smell, nothing. No shorts in the thing. Yeah, it's a real weird one. So I'm just gonna measure the fuses with my big fluke. and we'll see what's what. But yeah, it's a bit of a strange one. So I imagine, yeah. We got another mock setup here, courtesy of our Wago friends. So master sensor and a slave sensor, and a override off push button. So so that's my one. There's two circuits on the board there. So we got one light here. That's an emergency light. That's why it's on. Hello. Hello. Travis, not working now. What about this one? Maybe we've overridden it off. Oh yeah, there we go. Alright, so on and on. On and on and on. Now I think it should go off again. Maybe I'm a bit close. No. Try and film something and it just fucking doesn't work, does it?
Again, whereabouts is it?
Everyone just take my word for it, it works. I'm gonna sneak up on it. Yeah, stupid fucking thing. So it should have gone off by now, right? Oh, yeah. There we go.
Got to do it for the configuration.
Oops. Cool fucking bananas, mate. Cool bananas. This goes to show, when in doubt, test her out, mate. Test it out. When in doubt, test it out. Dangerously, too. Just halfway through tackling this monstrosity. The 7-gang switchblade. So, the cables are labelled in there. And it's, I think, 8, including the feed. So I'd double up the BP connectors and just put a link in between them. I tried to get all 8 in there, but didn't quite fit. It was close though, it was close. Alright, so they're the switches. They're not a clipsal switch. I'm not sure how I feel about, but that's fine. My only concern with these is I'm halfway thought they were supposed to be double pole, like isolate the neutral and the. That's why I ran all the switch wire neutral earths to here, because I thought they were double pole switches, but I guess these guys know better than me. ESCO, they do this shit all the time. They build these panels and they line isolation monitors, and we've got a few other panels in this room now. Just got those 2 little ones to go, so it's coming along. Hey everyone, I've had a disjointed day today, but between yesterday and today, I've got most of this room done. I'll spin you around. I've got an issue here. These panels here are, looks like this. So that's a nurse call, and then a spare, and then a switch. But what I've got here, this room has a laser light, and it's got to have an X-ray light. So I'll show you out here. What they look like there, so that'll be the laser light, and the X-ray lights are still to come. The same looking fitting, but here this blue cable here. So in the center of that room, that's a big HEPA filter. And in the center is a mount for a surgical light. So a big fuck off light. This Cat 6 here is supposed to be the control for that. I'm trying to work out from the manufacturer what sort of, whether this is a button, whether I can use that little switch there or what, because I need to know, because when these were designed, we didn't have the X-ray light planned into the medical services panel. So that little switch there is going to be the laser light, which for the laser, it's just a normal switch Mac. But they're not particularly easy to modify, these plates, unless I cut out like a whole thing. But that's its own whole problem. I want to cut that out if we can avoid it. So we've got the emergency and staff assist nurse call points, and then I was hoping to use that plate. But if they need a, I'll show you what they look like. So like this is like a Series 2000 clips or Series 2000 size. So that's a normal plate in behind there, but you only see that instead of having the cover plate. So it's a bit of an interesting situation, but instead of having that cover plate, you know, that would go on there. It's that size, so that's how they work. Anywho, I've got to work this out. This is a little bit of an issue. This is boring for a video. Anyway, I'm packing up here for the day and I'm going to go home. So it's always a freaking mission packing up, because I've got fucking pack outs everywhere. Pack outs, more pack outs, and then like I've got the whole trolley as well. Fucking a lot of work every day, in and out, but I seem to need everything. I don't know, maybe I should consolidate one of these boxes and make it a little bit more conducive to bringing less boxes in, but then the boxes get too heavy. So what I've found is just having more boxes that are a bit lighter, because picking these freaking things up to get them in the car is fucking my back over. Anyway, alright, same time. See yous.